So, we are going to see the concept of complex numbers today. Now, the concept of complex numbers starts from, see, we have been solving normal equations like this. If I have x square minus 4 equals to 0, then x square is 4 and x is plus minus 2. Now, what we have been doing for the quadratic equation is that we have been solving like this. Now, what if I have x square plus 4 equals to 0? So, x square becomes minus 4 and x becomes root under minus 4. Now, this is where we start with the concept of complex numbers. This is the beginning of the concept of complex numbers. Now, how do we evaluate this? At till a certain level, when we are studying in the primary or the middle or the secondary level, we call this as an undefined number and we leave it. But here we intend to know its value. The concept of complex number starts from here. It's a complete chapter, it's a complete phenomenon. Now, how is it exactly? What the mathematicians have done from here is, they have assumed that I will be root under minus 1. Now, that's the most important thing to begin with. I will be root under minus 1. Now, that's a conventional alphabet which is used in mathematics at any level. If you are facing an I, a small I, it means it is root under minus 1. So, now with the help of this particular equation or this particular value can be evaluated. Now, how is that? X is root under 4 into root under minus 1 and x will be plus minus 2 and I. Yes. So, that is the origination of the concept of complex number. So, if x square plus 4 is 0, then x will be plus minus 2i. We call it as complex roots or imaginary roots. These are real roots and these are imaginary roots. But at this level, the equations are solvable. We have to or we can get the answers. Obviously, we will call it as complex roots, but they are possible. They can be solved. So, this is where we start. Now, what are the other aspects? How do we actually proceed with it? So, as we have said that I is root under minus 1, what happens if I square it on both sides? So, I square will be minus 1 and I cube will be I square into I, which is minus I, and I to the power of 4 will be I square whole square, which is minus 1 whole square, which is 1. So, these are the 4 important values of I. Values of I. I is root under minus 1, I square is minus 1, I cube is minus I, and I to the power of 4 is 1. So, we have to remember these set of values if we intend to go ahead with the discussion. Once again, I is root under minus 1, I square is minus 1, I cube is minus I, and I to the power of 4 is 1. Now, to begin with the problems, to begin with the different questions related to the complex numbers, at the basic level, at the beginning level, we have sums like, we have to evaluate the values of, or we have to find the values of, say I to the power of 39. How do we get the value of I to the power of 39? Again, we only have I square, I to the power of 3 and I to the power of 4. Now, just see what exactly we are doing. It's I to the power of 36 into I cube, and I to the power of 36 is I to the power of 4 whole thing to the power of 9 and into minus I. So, that is 1 into minus I, which is minus I. If I have to find out the value of I to the power of 50 or 36 or 32, then it is I to the power of 4 whole thing to the power of 8, that means 1 to the power of 8, which is 1. If we intend to find the value of I to the power of, say, minus 98 or 99, we can write it as 1 by I to the power of 99, which can be written as I divided by I to the power of 100, and it's a multiple of 4, so that will be 1, so it's nothing but I. So see, these are the different ways in which we calculate the different exponents of I. Again, I to the power of 4 is 1, so we intend to reach to the nearest multiple of 4, and then after we put the other values. Look at all of them, you will find that we have calculated the nearest multiple of 4. So that is one aspect what we see as a problem when we are studying or when we are starting with the concept of complex numbers. How do we deal with the different values of I? At times we have some more complicated problems, like we have to evaluate or simplify, say simplify I to the power of 4 plus I cube minus I to the power of 6 divided by 1 plus I whole square or something like that. We have to simplify this. So as we know, this will be 1, this will be minus I, and I to the power of 6 will be I to the power of 4 into I squared divided by 1 plus 2I plus I squared. So that becomes 1 minus I minus 1 into minus 1 divided by 1 plus 2I minus 1. I square is minus 1. So we have it as 1 minus I plus I divided by 2I. So we have 2 minus I divided by 2I, or we can write it as 2I minus I square divided by 2I square. So that's 2I plus 1 divided by minus 2. So this is how we evaluate the different values of I. That is the beginning or the primary concept of complex numbers. Now to go ahead with it, what we say is a complex number in complete form, as we said that I is root under minus 1 and we saw so many things happening. A complex number is in complete form is just not about I. A complex number in complete form has been taken as, say, z equals x plus iy. Yes, that is the proper definition of a complex number. Here we start from. So where x is called the real part and y is called the imaginary part. So a complex number in complete sense means the form of x plus iy, where x is the real part and y is the imaginary part. We can think of some examples. Say for example, a complex number z1 is 2 minus 3n. Or we can have our example, say complex number z2 is 1 by 2 plus 5 by 7i. So they are some examples of complex number what we are going to see from now. So that is a complete complex number to understand, which has got a real part and an imaginary part, x being the real part and y being the imaginary part. Now at the beginning stage, a student has to be totally aware that how do we actually convert a given complex number in the form of x plus iy form. Now somewhere in some cases in some books it is also followed as a plus bi form. So nothing to be confused with, it can be either x plus iy form or a plus bi form. Now how do we express, a given complex number in standard form? Yes, the entire concept of complex number will rotate on the pivot of this phenomenon. Everything we learn from here onwards has to be taken to the form of x plus iy. So that plays a very vital role as far as complex number is concerned. Say for example, This is a complex number 1 plus I divided by 1 minus I. We have to find out its value. We have to express it in the form of a plus bi. Or we have to simplify. Questions can be in different form. The ultimate idea is that it has to be expressed in the standard form. So it is 1 plus I into 1 plus I divided by 1 minus I into 1 plus I. So that is 1 plus I whole square divided by 1 minus I square, and that is 1 plus 2I plus I square divided by 1 plus 1. I square is minus 1. So we have it as 1 minus 1 plus 2I divided by 2, which is I. So it is 0 plus I. That's the standard value of this 1 plus I divided by 1 minus I. So this is how we actually present it in the form of that x plus iy form or a plus bi form. Any complex number has to be expressed in this form. So as I said, that's the most pivotal thing of the entire concept. Let's see some other things related to it. For example, if we have a complex number, given in the form of say 1 plus I whole cube divided by 1 plus I or 1 minus I plus 2I plus 6. Now we have to find out the a plus ib form of it or the x plus iy form of it. As we have been seeing, first expanding it, 1 plus 3I square plus 3I plus I cube divided by 1 minus I plus 2I plus 6. So that is 1 minus 3, I square is minus 1, plus 3I minus I cube is minus I, divided by 1 minus I plus 2I plus 6. So we have it as 1 minus 3, that's minus 2, plus 2I into 1 plus I divided by 1 square minus I square, multiplying with the conjugate, plus 2I plus 6. So we have it as minus 2 plus 2I minus 2I plus 2I squared divided by 1 plus 1 plus 2I plus 6. So we have it as minus 2 divided by 2 plus 2I plus 6. So that becomes minus 4 by 2 plus 2I plus 6. So that is 4 plus 2I. So that is the standard value of this particular complex number. So as I have been telling, these are the different ways through which we intend to find out or we actually express a given complex number in the form of x plus iy form. What comes next? Once we have learned how to express a complex number in the form of x plus iy or a plus bi, there are some calculations what we need to know. We have to learn some calculations based on it. Now what are they? A complex number z is equals to x plus iy. To start with, number 1, the first one, what is the conjugate? The conjugate of the complex number z, denoted as z bar, is x minus iy. So the conjugate of x plus iy will be x minus iy, and the conjugate of x minus iy will be x plus iy, vice versa. That means the sign of the imaginary part changes. What will be the z5, suppose for example, has minus 3I plus 4. So if we intend to find out the conjugate of this, there is a very common thinking. I have seen people writing z bar as minus 3I minus 4, which is actually wrong. the concept of conjugate is not about changing the sign of the real part, but it is about the imaginary part. That means, first of all, Z5 has to be written as 4 minus 3i, and then Z5 bar, that means the conjugate of Z5 is 4 plus 3i. So care has to be taken once we are learning the conjugate of a complex number. The conjugate is actually the imaginary part with the opposite sign. The next thing after conjugate is the modulus. What is modulus of a complex number? The modulus of z, denoted as mod z, is root over x square plus y square. The amplitude tan theta is given as y by x. The real part Re of z is x. The imaginary part Im of z is y. And a very important calculation we have, the sixth one, z inverse is 1 by 1 x plus iy. Now it has to be again converted into x plus iy form. We need to see something related to it. So these are some of the important calculations based upon at the primary level, at the basic levels, which we have to calculate for a complex number. Now let's take an example to understand what exactly this calculation means. Suppose a complex number z is given as 2 plus 3i divided by 1 plus i, and we have to calculate its conjugate, its modulus, its amplitude, its real part, its imaginary part, its inverse. Again, we take up from the idea it has to be expressed in the form of x plus iy. So z will be 2 plus 3i into 1 minus I divided by 1 square minus I square. So that is 2 minus 2i plus 3i minus 3i square divided by 1 plus 1, not forgetting that I square is minus 1. So that becomes 2 plus I plus 3 divided by 2. So that is 5 plus I by 2, which is 5 by 2 plus 1 by 2i. See the way it has been written. So that is the standard form of that complex number. Now, number 1, the conjugate z bar is 5 by 2 minus 1 by 2i. Number 2, the modulus is root under 5 by 2 whole square plus 1 by 2 whole square, that's root under 25 by 4 plus 1 by 4, that's root under 26 by 4. Number 3, the amplitude, that's tan theta equals 1 by 2 divided by 5 by 2 y by x. So that's 1 by 5. Number 4, the real part of z is 5 by 2. The imaginary part of z is 1 by 2. And the most interesting one, number 6, z inverse is 1 by 5 by 2 plus 1 by 2i, that is 2 divided by 5 plus I. Again it has to be expressed as, so that becomes 10 minus I divided by 26, that's 10 by 26 minus 1 by 26i. So that is the conjugate, that is the inverse of z. Thank you.